Hello everyone, and in this video we're looking at a past paper question for thermodynamics, winter 2016, paper 4 to question number 3. Let's just start with it. So the A part says, what is meant by the internal energy of a system? Internal energy of a system is defined, we've discussed this like in the very beginning of the chapter, that it is defined by the sum of random distribution of kinetic energy and random distribution of potential energy. So we discussed this like in the very beginning, that this, first of all, random distribution is extremely important. If you don't write this, you won't get a mark. So it's for 2 marks. So 1 mark is for the random distribution and 1 mark for the sum of the kinetic energy and potential energy. Second part says, explain by reference to work done and heating whether the internal energy of the following increases, decreases, or remain constant. So whenever you get these questions, first thing first, I would suggest you write down, if work done on the gas, that means the volume, it decreases, but if the work is done by the gas, then the volume, it increases. And when the work is done on the gas, the internal energy, it increases, and here internal energy decreases, something we just did in our last video. So first is the gas in a toy balloon, when the balloon bursts suddenly. Okay, so you have a balloon. Okay, let's imagine you have a balloon, and then the balloon, it burst suddenly, which means there were gas particles, and they started doing work on this, and it just burst. So they were trying to move up when the balloon burst. So the work is done by the gas. Okay, so you have to determine that first. Work is done by the gas, so we have to refer it to work done and heating. First, work done by the gas is for 3 marks. 1 mark for this. Work is done by the gas. And what about heating? In this case, when the work is done on the system, the heat is supplied to the system. Heat is supplied to the system. So think about this. If the heat was supplied to the system, to these particles, that is when they gained more kinetic energy and they became more frantic and they started moving more violently. That is why we would say the heat is supplied to the system. So I would say heat supplied to the system. So internal energy increases. So that is how you get 3 marks. What happens to work, what happens to heat, what happens, you have to determine, you have to just sort of like envision the image in your mind, and you will be able to solve it then. Let's see the second. Ice melting at constant temperature and at atmospheric pressure to form water that is more dense than the ice. That gives us the big hint. To form water that is more dense. So when we mean more dense, that means the particles are more close to each other, right? The particles are more close to each other. That means the volume, it decreases, right? The volume to form water that is more dense. The volume, the particles are more closer to each other. That means the work is done on the gas, because the volume, it decreases. The volume decreases. That means you're pushing them to get to each other, right? So work done. So we would say work done. So once you determine what happens to the volume, that means we will say work done on the particles. And also, if it's melting from ice to water, that means you're supplying heat. Obviously you're supplying heat. So we would say heat supplied to the system to melt it, and that means internal energy decreases. Also, in this, work done by the gas, the heat is not supplied to the system. It only says that the toy balloon burst suddenly. So we're not saying that we're heating it or we're giving anything, any energy. We're just saying that it just burst. That means that the heat energy it's supplied is released from the system, because when the balloon burst, all of the heat, all of the particles, they just escape. So released from the system. So whenever you have to do this question, first you write down the things that you already know. Work done on the gas. When the work is done on the gas, the volume decreases, the internal energy increases, and heat is supplied to the system. In this, heat is released from the system. And then you think of the scenario and how do not assume things like I did in this. My bad. I just assume that heat is supplied, which is not. They haven't mentioned that heat is supplied. They're just saying that the balloon burst, right? So the balloon just burst. That means all of it escapes. So the heat is released from the system, and that is how you'll be able to do these questions.